So let's do these next three problems. So these are kind of unique, at least numbers 4 and 5 are unique in that we only have one variable represented. So for instance, in 4 we have the equation y equals 7. Now y equals 7, again, doesn't look like it's great in slope-intercept form. It could be in slope-intercept form if we would get rid of the mx. One way to do that, by the way, is to pretend that what we have is 0x plus 7. So technically we could think of this as slope 0 and y-intercept of 0 comma 7. Now I actually prefer to look at it another way. Instead of utilizing the slope-intercept form when I only have one variable, what I like to do is drop back into section 2.1 and think about it in terms of a table. Now, remember, our equation here is y equals 7. So if I plugged in a value of 0 for x, what would the value of y be? Well, you'd say, well, y equals 7. If I said, well, what if I change the value of x to, let's say, a 2? What would y have to be? Well, y still has to be 7. No matter what I plug in for x, there's really no x to plug in here. So since there's no x to plug in, y is simply just always 7, regardless of the x value we choose. So if I chose a 3 for the x value, y would still be 7. Or if I chose a negative 3, or if I chose a negative 1. Basically, put any number you want in for the x value. The y value has to be 7. Now this means it's pretty easy to graph. So when we go to our graph, I go 0, 7, 2, 3, 4, 5, 6, 7 is right there. And what did I say? 1, 7, 2, 7, 3, 7, negative 3, 7, negative 2, 7. I could have gone anything, right? 7, 7, negative 5, 7, right? You get this horizontal line. And that's kind of the interesting, whoops, I kind of messed that up a little bit. I kind of raised it a little bit. In fact, let me undo that just so I can graph a little bit nicer. I forgot I was using the cursor instead of trying to use a straight line. So here's what we get. We get a horizontal line that goes through lots of different points. All of those points have y value of 7. And there you go. And by the way, if I ask you a question like this, I probably will not ask you for the slope and the y-intercept of this equation. I'd probably just ask you to graph it or identify it. So let's go on to the next one. The next one's very similar. X equals negative 2. X equals negative 2. Well, we're going to treat it just like we did y equals 7. We're going to think about it in table format. This example really demonstrates the advantage of this table format as opposed to trying to force everything into the slope-intercept form when we have just one variable. Notice that x equals negative 2. There's no way I can get a y by itself on the left-hand side of this equation. So there's really no way I can put this into a slope-intercept form that would make sense. So it's not going to make sense to have a slope or a y-intercept in this case. However, if I'm thinking about tables, x always has to be negative 2. So whatever I plug in, I could plug in a number for y like 1. I just have to make sure x is negative 2. If I make another number for y, let's say 0, What's x have to be? Well, x has to be -2. If I plug in 5, x has to be -2. So in other words, I'm kind of reversing. I'm plugging in for y and solving for x. Plug in -3 for y, x still is -2. Anything you could plug in for y, including -2 itself, x has to be -2. So let's go ahead and graph this. And I'm going to graph this on the same graph I graphed the previous y equals 7, just so we can see some of the distinctions here. So x is -2, y can be anything, but what we chose was y is 1, 2, 3. As long as x is -2, y could be anything. And notice what we're getting here. We're getting a vertical line. So we get this vertical line. Ooh, put an arrow at both ends so we know that pattern goes on forever. And that's what we come up with. Okay? By the way, this vertical line, it doesn't have a really good way to put it into slope-intercept form. But remember, the slope in particular, was the change in y over the change in x. That's why this blue line, the y equals 7 line, had slope of 0. If you think about how much y is changing from going from one point to the next, the y value never changes. The y value is always 7. The x value is changing. So we're changing by 0 in the y direction, but by 1 in the x direction. 0 over 1 is 0. That's why the slope was 0 with this blue line. As far as the vertical line goes, well, the y value is changing, but the x value never changes. So if you think about y value changes by 1, if the x value changes by 0, that's a fraction of 1 divided by 0, which is an undefined number. Remember, we can't divide by 0. So technically, in this vertical line, the slope is either undefined, or some people will say infinite. I'll say undefined. By the way, also in that vertical line, think about where this crosses the y-axis. Well, we can see that this red line, any vertical line, will never cross the y-axis. So vertical lines also do not have a y-intercept. All right, so there you go. Again, I'm not going to be asking you for the slope or the y-intercept of a line like x equals -2, but I did want to at least address that. So that's how we deal with vertical and horizontal lines. They come out of y equals a number or x equals a number. I always think about graphing them using that table method that we dealt with in section 2.1. I think that's a little bit easier and a little bit easier to understand. So let's do this last example. Y minus 1 equals -2/5 x. This has both a y and an x, so I can put it in slope-intercept form. It is not currently in slope-intercept form, so let's go ahead and do that. The way to do that in this equation is just to add 1 to both sides. So I'm going to take y minus 1 equals -2/5 x. I'm going to add 1 to the left-hand side. That's going to give me y. I add 1 to the right-hand side. It gets me 2/5 x plus 1. Okay. Now I read off the slope. The slope is -2/5. The y-intercept, again, don't mess this up. The y-intercept is the point 0, comma 1. It is not 1, it is the point 0, 1. Same thing with the slope. Don't write negative 2/5 x. Negative 2/5 x is not the slope. Negative 2/5 is the slope. There's no x on the slope. All right, so there we go. So that's all we need to go ahead and start graphing. All right, so let's go to 0, 1, or y-intercept. There it is. And negative 2/5, I'm going to think about that as negative 2 over a positive 5 for my change in y versus my change in x. So change in y is negative 2. That means I need to go down 2. Change in x is positive 5, so I need to go to the right 5. I can do that again if I want. Go down 2 and to the right 5. Now we see the pattern. By the way, if you would have rather, you could have went a positive 2 over negative 5. That's the same thing as negative 2/5. You could put the negative on top or on bottom. We know that positive divided by a negative is the same thing as negative divided by a positive. So if you wanted to, you could have went up 2, right? Positive 2 in the y direction. And then negative 5 in the left direction, excuse me, in the x direction means go left 5 units. And notice you get the same exact pattern, whichever way you do it. So there we are. There is our pattern. Now we create this line. Put arrows at the ends so that we know it goes on forever. And there you go. So that's how we're going to graph using the slope-intercept form of the equation. You can do the other problems in section 2.2, both the cooperative group problems and the at-home practice problems on your own.